Fine, guys. Here our topic is today OSPF, Open Shortest Path First. OSPF. See, in OSPF, it is like link state routing protocol. Link state routing protocol. What does it mean? Means the router, whichever OSPF router having, it's here we have multiple routers in our network. For example, I am taking here 4 routers. These all the routers are directly connected to each other. It's a point-to-point network. You can assume it's directly connected to each other. This router is directly connected to this router, the next hop of this IP address, and this router is directly connected to this router, and this router is directly connected to this router. In static and default routing, we know the destination IP address, then only we can configure those routing protocols. We don't know the destination IP address, we cannot configure the static and default routing. But in this case, in dynamic routing protocol, no need to know the destination IP address. These are for having one LAN network. For example, this is 10.1.1.0/24. This network have for this R4 LAN. This is a LAN, local area network. It is connected to again switch. The switch is connected to end users, like so many end users. This is a switch, and this switch is connected to one end users. So many end users we have, and that so many end users we have a 254 IP address. Only I am taking as only one network here. In this, it's our destination. Our source is at different location. We have connected one end users wants to communicate. This end users wants to communicate. He's using 192.168.1.10 IP address of this host having. Subnet mask is 224. This host wants to communicate this user. It's kind of server also. Here one more server is there. In this server, application is there. It's a data center, you can assume likewise. Okay, the R1, whenever we configure static routing, the destination address we know, then only we configure. Dynamic also, dynamic part no need to configure. It's a dynamically unknown the destination, we'll configure. It's unsecure totally. 0.0.0. Sorry, default routing as 0. Whenever the destination host is unknown, that time we'll configure as a default routing. But in our dynamic routing protocols, no need to know the destination IP address also. Just know the directly connected interface will advertise in with the help of network command will advertise this prefixes. This whichever we are using in between in this segment, whichever IP address we are using will advertise this will advertise with the help of network command will advertise this prefix. Then directly the neighborship will be formed in between two routers. Whenever we are configuring OSPF, it's a dynamic routing protocol. Just we configured OSPF, then we'll advertise these prefixes and this segment prefixes and this segment prefixes. Once we configured the link state, then the what about the link state? In RIP as a work as a hop count metric, as a hop count, like it will be work on it is a distance vector routing protocol. It will be having how many distance are there, it will be carried that many distance. But in link state, this router R2 R3, no, listen properly. In this link state means link state routing protocol, link state, every link this router R1 having every router information, this router will send to this router. I do have 10 dot prefix, 10.1.1.1. I have this prefix. Then this router also will send to this router. Then this router will send to this router. To this prefix, at this prefix I do have this prefix information. It with the help of we have some process is there. We'll discuss that process, how it will be sent that IP address and all. But every router having every routing link information. Every router having, if we have if you can assume like here we have 100 routers. In that case, whenever we advertise the prefix, okay, this is the 100th router, 100 router. Whenever we advertise the prefix of 10.1.1.1, it will be within a some timer is there. In the timer, it will be sent to all the whichever connected routers, it will be sent that prefix. I have this information. Fine. It will be sent every link, every router having every router information. That is that we call it as a link state routing protocol. All good? Guys, do you have any questions? Link state routing protocol. Anyone have any questions? Then we'll go to the next step. Fine. OSPF stands for Open Shortest Path First. It's open standard routing protocol. It will be work in Cisco also and non-Cisco devices also. HP, Aruba, everywhere. In every vendor, it will be work. It's an open standard routing protocol. It is not like EAGRP. EAGRP is a Cisco proprietary protocol, but OSPF is an open standard routing protocol. And it's a link state routing protocol. We discussed link state routing protocol, and it is an interior gateway protocol. It will be work within a AS. It will be work within a AS. And what about metric? Metric is a cost. The cost, it means see, actually OSPF will maintain up to it will be do the load balancing, or it will be select the 4 equal cost path. It will be maintain the 4 equal path. If you have one router in the and you have one more route from this, and you have like, see, this is a Ethernet cable, and this one is a serial cable, and this one is the fast Ethernet cable, FE, fast Ethernet. But this one is a 1 gig cable. It will be calculate the based on the bandwidth. In this case, this is the best path. It will be on to see how many routers are in between, how many hops away the destination. It won't see. Once this path went down, it will be moved to the fast Ethernet. It will be calculate by in between also we'll use, like here we are using fast Ethernet. There here you will use serial port. Here we'll use serial port. Likewise, it will be calculate the path to path from source to destination. It will be calculate. It will be calculate from source to destination. How many hops away that router and in between which media we are using. It will be calculated based on that. Guys, any doubt in metric? How it is calculating? If you are not understanding, ask me the time only. If you are not understanding any question, the time only you ask. Otherwise, don't keep it in yourself only. That questions, guys. It's clear.
Yes.
Metric finish. The metric, it's like a 100 Mbps by a interface bandwidth. Like we have for bandwidth calculation part. This is the for gigabit. It's like 1 Gbps speed, and fast Ethernet we have 100 Mbps, and Ethernet interface like 10 Mbps. These are the serial interfaces. Okay, nowadays we are not using much more, but we are using like Ethernet interface and fast Ethernet. Nowadays everyone you are using like gigabit Ethernet only. Fine. For example, like here we have a formula like my screen is visible. 100. I'm taking here like fast Ethernet, FE, fast Ethernet. The bandwidth is fast Ethernet bandwidth is 100. It will be 1 likewise. If I am using here Ethernet port means 100 by 10. The value is 10. If I am using here gigabit port 100 by like 1000, you can take. It will be go to 2 zeros. Then we have some 0.1. So we'll not take 0 point values. We'll take as a 1 only. Now you will get the result. Check here. See, gigabit we are using as a cost is a 1, and fast Ethernet cost is 1, and Ethernet cost is 10. Okay, and these are the serial interfaces. I'll show you in lab for this. For metric part, I'll show you in lab. Good. Right. Now AD value is 110. The AD value is administrative distance is 110, and IP protocol number is 89. With the help of protocol number, will identify the service. With the help of protocol number, will identify the service whichever coming from upper layer. For like it will be work on layer 3, whichever protocol is coming from. It is like datagram protocol is coming. It will be with the help of protocol number will identify the service, which service is coming. For that, OSPF uses 89 in whenever we are creating policies, and all will use in firewall policies. Some will traffic deny or permit. That time will use as a these protocol numbers. For a time being, the protocol number is like identify the service, whichever coming from upper layer. Where we'll use in firewalls, we'll use like creating the policies or deny or permit some traffic. That time we'll use as a 89 protocol number. That is the OSPF. It is a unique number for this. Do you have any questions still up to here?
So for the bandwidth, if you take the gigabit,
Yeah,
says
gigabit.
one.
Yeah, one only. See, here we got the result like 0.1. We won't calculate like 0.1. If we have like 10 gig also, it will be get from 0.1 0 some value. Okay, will not take as a metric like 0 zeros. Okay, after point will not take. So the value is like 1 only. We will calculate as a 1 only. If you are taking 10 gig port also, in even the 40 gig port also, like 1 only will calculate as a only 1 metric, as a 1 metric. See here I have shown here only 1 port. 10 gig 1 gig port is 1 only. The metric value is 1. Fine, Ajay. Who asked this question?
It's me, Pawan.
Okay, fine. Pawan, it's good. Understood?
Yes, sir. Yeah, got it.
Fine, good. And what about multicast IP address? Here we have two type of multicast IP addresses, 224.0.0.5 and 224.0.0.6. See here, all the routers, whichever the router is there, it will be received with the help of 224.0.0.5, and whenever comes to DR&BDR, it's like a master router. In this topology, master router, the DR router only send the prefixes to all the neighbors, all the routers, with the whichever they got the prefixes. Because of, if DR&BDR router is not there, say, then we have like here LSA floodings. So we reduce that LSA floodings. So we are using a concept as DR&BDR. I'll explain in more later on sessions. For 224.0.05 is for all the routers, and 224.0.0.6 is for DR&BDR routers. Okay. We have a will discuss DR&BDR elections also. In that elections, you can understand what is DR router, designated router, and BDR, border designated backbone designated router. Okay. And it is a layer 3 protocol. It will be work on network layer. And by default, maximum path is 4. Up to maximum 4 path it will have, and up to we can increase like 16 path. Like path means we have one the source, like it will be maintained up to in between. Likewise 4 path. It will be calculate the best path and second best path. Whenever the first best path goes down, if this path goes down, then second best path. If this path also goes down, then third path. It will be calculate, it will be maintained up to 4 path. And what is a classless and classful? Yesterday we have discussed. We'll tell what is a classless and what is a classful routing protocol.
Classless means they carry subnet mask information, whereas a classful means they do not carry subnet mask information.
Good. Fine. Here it classless means it will be carry the subnet mask information. If we in this slash value 29 also, in this slash value 30 also, and this slash value like 28 also, if we advertise these prefixes, it will be carry the with the help of this subnet mask. But class full means it will be carry only for class, this kind of class A, class B, class C, 24. It will be understand whichever you advertise the prefix. If you are advertising likewise, it will be understand like it is a class C IP address. It will store likewise only. Whenever we configure in OSPF, it will be store like if class is 29, is subnet mask is 29 means it will be store like likewise only. But in class full means it won't store likewise. it won't carry the subnet mask. It will be carried, and classless is will be carry the with subnet mask. Understood? Yesterday, Monica, Pavan, you are not there, and Ajay. Understood?
Yesterday I
What is the
attended the class, sir.
Yeah, sorry, Ajay, Monica. Those guys are not there. Good. And now move to the. By default, auto summary is disabled. What does it mean by auto summary? Means summary. If we advertise like the prefix like 192, 168, this is 1.0 prefix /24 and 2./24 and 3./24. If 4 dot, this many prefixes we are advertising, but whenever we are advertising this many prefixes, router CPU we are using more. Okay, we are using more, so we have a concept like summarization. In this summarization, will advertise even though these all prefixes, once you get the summary, you will get like the IP address like 192, 168, 1.0. It's like 23. Only one prefix is in this, only one prefix, this all prefixes will come in this prefix, will filter the prefixes with the help of summary. The auto summary is disabled in this OSPF. The auto summary is disabled. Auto summary is by default disabled. If you want enable, if you are enable, then good. Understood? It uses SPF, shortest path first algorithm, for the best path selection. With the help of shortest path first algorithm, it will be select the best path. The formula is there. And types of messages here: hello, DBD, database description, link state request, link state update, link state acknowledgement. This is a hello hello message. What it will be carry? For in hello message, it is used to discover neighbor or establish the neighborship. See here, you configure as a OSPF here, and you configure as a OSPF router with the help of router OSPF, and give some OS some process ID like 10. Once you configure and advertise some network IP address, whichever you directly connected in this segment, you whichever file 10 dot something IP address you advertise it in this, then the neighborship will be formed in between routers. Then those routers will send hello packets. Hello myself, likewise hello myself router 1 and hello myself router 2, they both are sent to each other. In that router, it is used to discover a neighbor to or establish the neighborship, and they will send the keep alive messages to both each other. In periodically hello timer, they will send if any, in that here they are periodically send the information. Yesterday they like triggered update, like it will be whenever the any new changes are come or not, every time it will be sent new changes are coming or not, it will be send hello packets to everything in RIP protocol. But here it will be sent periodically. It means whenever any changes occur in this router, any changes in means whenever we advertise any prefixes, that time only it will be changed, send the messages to neighbor. Apart from that, it won't send. If any changes occurred, if any changes came, if any prefixes we advertised in this router, that time only it will send. Otherwise, it won't send. Okay, the timer is like 10 and 30. That is why 10 and 30? It means in point-to-point network, the 30 here we have network types. In that point-to-point means it will be sent 10. And if we are using broadcast means non-broadcast or broadcast network, that time it will be used as a 30-second hello timer. It will be 4 times 2 of dead timer. If find whenever the neighborship went down, it will be wait up to 40 seconds. For in point to point, it will be wait up to 120 second in multicast broadcast network. In broadcast network, it will be wait up to 120 second, but in point to point network, it will be wait like 40 seconds, 4 times. And multicast IP address like this. And whenever the replying giving, that time unicast. There are all the content of hello. The OSPF version it will be sent, and message type, which message type, and packet length, how much it is, like MTU size, maximum transmission unit it will be sent, and router ID it will be sent, area ID, and packet checksum, authentication data, subnet mask, hello timer, options, whichever means here we have like it's advanced concept options, and dead timer, and priority. By default priority is 1. It will be sent up to 255. The priority is there in this routers. It will be sent how much priority is there router in router, and DR, which one is DR, which one is BDR, it will be sent in this hello parameters in content, hello content message, the neighbor router ID also it will be sent. This is the content of hello message. Okay, fine. Before that, what we'll do, we'll discuss continuation of types of messages. We'll discuss like with the help of states. Okay. After then we'll move to the neighborship parameters. In this OSPF neighbor states, it will be passed on like this is my router 1, and like router B, A or B, you can take A or B. It will be like first, whenever the down means we haven't configured till OSPF. One side you configured and other side you haven't configured. But the router still it will be sent. Whenever you configure as a router, OSPF process ID, with the help of process ID, once you configured at one side and your other side you haven't configured, it will start sending the hello message, that is down state. In that hellos sent with router ID, hello, in hello message, what content we have, this content it will be sent. This all the content it will be sent in hello message. It will send version, message type, packet length, router ID, area ID, packet checksum, and packet checksum in the sense any error is there. Okay. And authentication, which authentication, here we are using MD5 and SHA algorithm. SHA, 2 types of authentication types. MD5 will use mostly, and authentication data, and subnet mask, hello timer, options, dead timer, priority, everything it will be sent. Whenever you configured as a router in router OSPF, one side you configured as a routing type, that is OSPF, and other side you haven't configured till, that is down state. Send with router ID, everything is sending, but it is not sending, not receiving anything from neighbor. And what about initialization. Init in the sense initialization. You can call it as attempt also. And hello send with a router ID. It is sending now. We configured at both end. Then it is send. We configured at. For example, you have configured in this router also OSPF and in this also OSPF. Then both routers are sending to each other hello messages. Hello sent with router ID. Hello received with neighbor router ID. Both are sending with router ID. Okay. Wait for a while. We'll discuss what is router ID. In this router ID, it means every router having one unique identity number. Every router having one unique identity number. That is, we call it as a router ID. Understood? Every router having one unique ID, that is router ID. Router elect its router ID to represent itself in OSPF domain. With the help of router ID only, it will be elect. It will be represent itself. Okay, it will be represent itself. I am the winner, likewise. I am the master, likewise. It is like we have like it is IPv4 type. IPv4 means 32 bits. Like 192, whichever, if you want 192, 168, 1.1, you can give, otherwise 1.1.1.1.1, like 2.2. Whichever IP address, but that is in IPv4 format. That is the router ID. Okay, how it will be elect in router ID? Manually configured of a router ID. First, whichever you have configured manually, just go to the OSPF, then give the router ID command, then give, that is the router ID, it will be elect. It means what the reason is router ID. See here you have its 4K series router. Here you have 2K series router, and this one also 2K series router. 4K, I want to make it is make it as a master. I want, because this 4K series is also costly, and this router is sit in data center. It is like hub location. These all are branch location. This is the branch location. This one is the branch location. In branch location, no need, right? In data center only, whichever our data center is there, in data center only, we all having the routers are masters. So with the help of manual configuration, I'll make it as a, this one is the master router. With the help of router ID only, it is possible. If you are not configuring manually, it will be select as a loopback IP address. Loopback, it means logical address. It is a logical address. It is not a physical IP address. It is a logical address. I'll show you in configuration what is loopback IP address. It is logical interface. It is always up only. We know no need to do the up. It is logically configuring. Well, logically configuring IP address. It is like kind of interface only. Again, it is a kind of interface only, but that is logical interface. Understood? In BGP concept, you will better you will understand that. But I'll show you here what is loopback IP address in the lab. Okay, and if you are not configuring as a logical interface also, that time it will be select as a whichever highest physical interface IP address. In this case, you configured here 192.168.1.1 and 190. I'll leave this. What is mean by that? This is the router. In this router, you have three interfaces. Here you configured 220. So for example, 200.1.1.1. Here you configured as a 192, 168, 1.1. Here you configured as a like 192, 168, 2.1. First it will be select likewise highest interface, whichever highest interface, that will be the loopback IP address, router IP address, router ID. It will be elect likewise whichever highest physical interface, that is the router ID concept. Guys, raise the questions. If you have any questions, please raise the questions.
Okay.
Everyone, no questions? See, in downstate, one side is not enabled router, OSPF, one side enable the router, OSPF, we enable routing protocol. In this init state, we enable both and they are exchanging a router ID. Then it once the exchanging the router IDs, hello parameters, then it will be moved to the two-way state. Okay, if one side is not configured, if one side is configured, then here only they struck. In any state only they will struck. They won't send to neighbor. Okay. Two-way state. In OSPF domain, if a router receive hello packets and that packet it seen its own router ID, then the router in two-way state, and DR and BDR election done in the state, and the router IDs both are sent to each other. Once this router will get the router ID and once this router will get the router ID, and after then whichever the highest, if we configured as a here like configured like one router ID like 192, 168 and 2.1 for this router and router ID for 1.1 this router, then it will be elect based on the highest prefix IP address, physical interface, highest prefix. It will be first, it will be select router ID, it will be moved to the highest loopback IP address, then it will be moved to the highest physical IP address. Then it will be select which one is the master. And this two-way state, it will be happen. And once two-way done, then they both exchange the database description, empty DBT packets. Now empty DBT, they will share and sequence number and which sequence through it is coming, and MTU size. MTU size is, it means maximum 1500. They together to send. And master slave election, higher router ID router will become master and initiate the database sharing. Whichever the highest router ID having, that will be select as a master router, and that router only send to all the router with the help of this IP address, with the help of this multicast IP address. Fine, it will be send. And after then it will be moved to the exchange, LSA, link state acknowledgement, header sharing. They both, everything they will share to each other. Here the empty DBD, then after then here the DBD will send database description, exchanging the database, whatever this router having 100 prefixes, this router having, and this router having 100 prefixes. They share together in exchange state. After then they'll move to the loading, send LSR, link state request, link state acknowledge. It means if you have anything miss or anything new prefixes came, 192, 168, some new prefixes came, please can you send, this router will ask, can you send that prefix also? Then they both send together. That is link state request, and it will be give the link state update. After then link state acknowledgement, it will be processed likewise. Received LSA from LSR, send LSL, that is link state request. That is the process, we call it as a link state acknowledgement, link state request, whichever. Okay, they will send to each other in loading state. After then finally they move to the full. It means neighborship established together. The router both are in finally full state. They establish the adjacency will be established. Adjacency in the sense they both are now neighbors. The process within a 10 seconds it will be happen in a 10 seconds. So it's a faster, convergence is fast. In 10 seconds the convergence is it will be done. It will be point to point network. But if it is broadcast network, that it will be take 30 seconds. Non-broadcast, broadcast, those kind of networks, it will be take 30 seconds. That is depending on network type of network. And whenever the here neighborship parameters are there, so both neighborship, if I want to make a neighborship with A to B, that time this all should be matched, then only. But in this router ID, both are different. If here you are using 1.1.1 for this router and 2.2.2.2 for this router, then in this case it will be unique. Yes, unique only in router ID it is unique, then only the both are form the neighborship. And router ID must match area ID must match. In this two neighbors are, if here you are using area 0, if you are using area 10, the neighborship won't form in between. In this segment both are in same area, then only the neighborship will be formed. Authentication type, whichever, if you are using MD5, then message digest value like MD5, both side MD5 and MD5 authentication type. MD5 in the sense password, you are giving some password after MD5 algorithm. With the help of MD5 authentication, you are giving some password. Here is Cisco and here also Cisco. If you are giving here Cisco 123 means it won't accept, the neighborship will be not formed. Okay, it will be not formed in between. And both the subnet mask, if you are using here subnet mask is like 24 and here 25, it will be not form the neighborship. Both in 24 only it will be formed. 24 in the sense 255.255.255.0. Both and 255.255.255.0, then only it will be neighborship will be formed. Otherwise, it won't form the neighborship. And timers also. It means here you are using point to point, other and you are using network type is different. The neighborship won't form. The timer also must match. Otherwise, you can change the timer also with the help. Some commands are there. With the help of commands, you can change the timer also. So if you are changing timers, then neighborship will be not formed. And MTU size, maximum transmission unit size. Here you are sending some 1500 packet size, and here you are sending some 1600 packet. Then the neighborship will be not formed. And stub flag. It's a stub flag means will filter the traffic with the help of stub. Stub areas is there. In that stub areas, if you are using here different stub and if you are using different stub, means it won't form the neighborship form. It won't form the neighborship. And OSPF network type, whichever point to point, if you are using here point to point, here using some different network type, that is broadcast type, it won't form the neighborship. These all are matched, then only neighborship will be formed in between routers. OSPF neighborship will be formed. If these all parameters match, then only neighborship form. If anything mismatch, then neighborship will be not formed. Some cases in real time also, if you are doing troubleshooting, some cases, if some interviewer raise the questions, in OSPF, you having two branches. In these two branches, branch 1 and branch 2, they are not forming neighborship. Then how you will troubleshoot? How you will troubleshoot? Then you answer it like, I'll check the router ID, I'll check the area ID, I'll check the authentication, I'll check the subnet mask, I'll check the hello timer, I'll check the MTU size, I'll check the stub flag. Likewise. Understood. This is the interview question also. Guys, I am audible?
Yes.
Any questions?
Can you explain one more time for the stub flag?
Yeah, okay, fine. In stub flag, actually, see, actually will filter the traffic actually with the help of stub will filter the traffic. Which traffic? This LSA traffic actually will filter the LSA 5, SBR LSA or external LSA will filter this traffic. Okay, you are configured one end as a, you have given one command here, you configure as in one side totally stub, and you configure one router as a only stub area, then it neighborship will not form. So you should have to configure both end same stub. If you are doing here one end as a stub and here you did a totally stub, that time neighborship will not form. Pawan, got it?
Yep.
Yeah, it's an advanced topic, don't worry, we will discuss later. But we are using like filter purpose, we are using unwanted traffic or CPU utilization is more, that time will filter this kind of traffic, and LSA flooding also will happen, that time we'll use this stub concept. And types of routers in OSPF. Before that, now we'll discuss what is a area concept, what is the requirement for the area concept. Okay. Up to here, do you have any queries? What we discussed till now? We discussed a brief about OSPF and how we'll calculate metric and IP protocol number and multicast IP addresses, and by default it is used like for path and classless, classful. We discussed how it is using the shortest path first algorithm. Okay, and message type we discussed, and hello parameters, these all are, and router ID concept, how it is elected router ID, how to elect router ID we discussed, and neighborship parameters and states we discussed. Up to here, any queries? Pavan, Monica, Ajay, anyone? Yamuna? Guys,
No,
Yeah.
you can go.
fine. Why you don't have questions? The explanation is very well, or you are not understanding?
Now, the thing is, I mean, I need to go through for the extra class and as well. So I'm good with that right now. So if I had any doubt, I'll just ask you again.
Go, great, Ajay, great. Fine. Here we have types of router in OSPF. See, before that, we concept having in OSPF area concept. See, you have multiple routers. You have multiple routers in your network topology. This kind of network topology, you have multiple routers. This is one branch location, and this one is branch location. This is kind of hub location. Okay. And what is the requirement for the backbone area? Okay, these all are the non-backbone areas. Okay, backbone area only having like area 0. Area 0. These all are the area 10. What is the requirement for this concept? Area 20. Because the area 0 is like it will be backbone of network. If area 0 is not in between the two areas, the neighborship also not form. They won't form the neighborship in between together in these two routers. No, they will not share the information. They will not share the prefixes. So we must and should area 0. The area 0 is like hub location. The area 0 is like hub location. You can assume these all are spoke locations. Here, like kind of hub to spoke topology, if you want to create, then we are using like this kind of concept. So here here we having LSA, link state acknowledgement. It means every router, if this router having 1000 prefixes in this branch having 1000 prefixes, not even the 1000 lakhs of prefixes. That time this router like we should have to maintain high-end configure router. High-end configure, it means 4K series or 5K series routers we should have to maintain. It is costly, so we'll maintain as like only hub location at one high-end router will maintain, and apart from that branch locations we will maintain low-end, low configured routers. Low-end, it might be like 2K series kind of routers. The basic requirement for this only, for area 0, it's a backbone of area, and this area we call it as a ABR, area border router. Understood? If the prefixes coming from BGP, So in between, if you are configured, that router we call it as a exterior. ABR, sorry, autonomous system boundary router. That we call it as a autonomous system boundary router. What it means? The prefixes coming from redistribution, coming from another routing protocol, coming from like EIGRP. EIGRP. You are redistributed, or RIP, from RIP you are redistributed prefixes. These all are ABR. That time we call it as a ABR router. This one is ABR router, and whichever the area border router it means, in between two different areas, area border routers, and it's a backbone area also, we call it as. Backbone in the sense it's a zero, should configured in between two different areas, like here this is area 0, A0, and it is coming from, this is different area 10 and area 20. You cannot configure likewise directly. You need a backbone area, definitely. All interfaces are in non-backbone areas, like these are the non-backbone areas. These all are the non-backbone areas, different areas. And ABR in the sense area border router. This one is the area border router. And ASBR, autonomous system boundary router, means coming from different routing protocols. Like this is you configure as a in between OSPF. Here you configure as a OSPF, but you redistributed, and some prefixes are coming RIP, the RIP protocol coming to this network. These all we call it as a some redistribution prefixes. We call it as a ABR, area autonomous system boundary router. Redistribution prefixes. Good. Any questions? And someone asked about these questions. I think Yamuna. In starting.
It's about ABR.
Yes. Now clear?
Yeah.
Fine. The ABR. At least one interface in the backbone area and one interface in the non-backbone area. That router is called ABR. See, one interface here, one interface is area 0, and another interface is another. I'll give you a brief for this. Wait. Good manner. You are not under. See. This one is area 0. These all are in area. Fine. Fine. Guys, this is the backbone of area. In between, one interface is in 0 and one interface in different area. This router is called as a ABR. And now coming to here, understood, this is called as a ABR. One interface in area, and this interface is like we configured here RIP. That prefix is coming from different area. This router is a ABR router. ASBR, Autonomous System Boundary Router. This router is a ABR and this router is a ASBR. This one is a backbone router. If you have some different router here in this OSPF, these all are different routers. Like we call it as a internal routers. All the interfaces are in non-backbone area. This one is a ABR router, area border router, and ASBR router, and this is the backbone router. One interface is in area 0. This one is area 0 actually. This one is area 0. At least one interface is in backbone area and one interface is in non-backbone area. That router is called ABR. The router where we perform the redistribution, that router is called ASBR. See, here we are performing redistribution, the RIP to OSPF, the RIP to OSPF, that is the reason ASBR, and here one is in another area and one is in area 0. Even though you should have to tell this interface as a area 0, then only neighborship will be formed in between. Otherwise, it won't form the neighborship. Yamuna, clear?
Yes.
Anyone have any queries still up to? And we having 3 types of table: neighbor table, database table, and routing table. And neighbor table means you have whichever connected directly neighbors. This is the neighbor table in between. And database table means this is area 1, area 0, and area 10. In between, whichever the prefixes come, that will be database table. It will become. And the routing table means which is a common routing table. Contain the best path each destination. Whichever the destination is there, in between, if we have multiple path, this will be maintained. Even though we'll check in a lab for this, we'll start lab. If you don't have any queries, we'll start lab now. If you have in theoretically any questions till what we discussed. the yesterday configuration. I'm changing little bit here only changes. Doing this interface now. Time. Enable show IP protocol. I'm removing the RIP protocol. Show IP protocol with the help of protocols. See, I have removed. Earlier we configured as a RIP protocol in last lab. Enable show IP protocols. Here RIP protocol is a config T no router RIP show IP protocols. No protocol is there. Enable show IP protocols. Only the protocol show no router RIP. Fine. Right. So IP interface brief. You can check whichever interfaces is there. Just IP assigned that interfaces, nothing much more, and no configuration I did till now. Leave that interface now for time being, because yesterday we did directly connected to this interface to this interface. Now no need that. Fine. You can check here in this router configuration part, show IP interface brief. Fast Ethernet 0/0 and fast Ethernet 1/0. For this fast Ethernet 1/0, and I have 3 prefixes. Show IP route. Check only directly connected and show IP interface brief. Here I have this is and this configuration till anyone having any queries, guys. What we did yesterday, just I have assigned the IP addresses to every PC here, like in this IP assignment, just IP config. You can check just I have given the IP address to every PC. In switch, I haven't configured anything. No configuration is there. Nothing is changes. Direct only switch, L2 switch. And in this router only, I have assigned the IP addresses for this interface and this interface. I have assigned 2 interfaces only. Now leave it this. Now, if you have any queries, we'll discuss. Otherwise, we'll move to the lab. Guys, this configuration part is okay. Ajay, Monica, yesterday you are not there. That is the reason I am asking. Abhinav, do you have any questions? Okay, Abhinav, what is the AD value of OSPF? How router ID will be elect? Who will answer it? How router ID will be elect? Anyone can answer it. How the router ID
So
elect?
router select its router ID to manual configuration of router ID
Okay.
and physical interface of IP address highest and highest loopback in IP address.
Is it right, Yamuna?
Okay, Nishan. I'm sorry, Alam, I just got a call from my mother. I just missed it.
Sai what he explained, right?
Like router ID, it elects mainly 32 decimal number IPv4 format.
Okay. How it will be elect? Some parameters, a criteria is there for router ID election.
Like a
Highest loopback.
neighborship parameters.
No. Router ID election.
It's like it selects the highest physical interface IP.
Highest physical interface IP. First one.
Mm.
It will be checked. Monica, is it right? First it will be select.
Highest loopback IP address.
First it will be check highest loopback IP address.
No, it's the second one. First, it will check the highest
First, it
interface.
check the manual. Will
I
check the
have
manually configured router ID
okay. Then
and then the loopback IP address, highest loopback IP address,
okay.
and then the highest physical interface IP address.
Is it right? Good. Ajay, first it will be
Yes,
select the
it's right.
manual router ID, then the loopback IP address, then physical IP address, highest physical IP address. Fine. Good. See, I am configuring here and router 0. I will change the host name first. Config T host name R1 and router OSPF. Then here some process ID is there. Process ID where we'll use basically this is your ISP. ISP having two different customers. Customer ABC, ABC and customer XYZ. Here the ISP will use for identification purpose for this for 10 process ID and this for 20. Whenever they use OSPF protocol, OSPF and OSPF they will use that time they'll use process ID for differentiating the customer A, B, C and XYZ for differentiating the customer ID customer, then they'll use different process ID. The process ID range 65535 2 to the power of 6 value 16 2 to the power of 16 65535. Okay, the range is up to here. What is the requirement process ID? What is the requirement for process ID? differentiate the customer. To differentiate the customer, ISP will use process ID. Guys, clear? If someone asked you a question, process ID, but in same organization, they use only one process ID, whichever the requirement purpose. Randomly they will take in between, whichever. But mainly we'll use ISP, guys. See, I'm taking here any process ID like 100. Here you can take 200 also. Here you can take 300 also. No issue. That neighborship will be found. No issue on that. Process ID, if different, also no issue. In neighborship parameters also I haven't mentioned for process ID. But area ID mentioned. Area ID is must match. And I'm doing here. I advertise the networks for directly connected interfaces neighbors and whichever our LAN interface IP addresses. Those I will advertise here. And 112.1.1.1, sorry, 0. And here we will use wildcard mask. What about the wildcard mask? Here the global subnet mask is like 255, 255, 255, 255. In that 255, I'm using here like class C. So the subnet mask is 255, 255, and 255. Subtract it. Cancel, cancel, cancel. Then you will get 0, 0, 0. The 255 value is 255. This is our wildcard mask. Wildcard mask. Any questions in wildcard mask? It's a subnet mask. Whenever you global subnet mask subscribe it, then you get the wildcard mask. Wildcard mask, W mask, wildcard bit. Opposite to subnet mask. Here you have how many host bits? Like in this host bits, 255, 255. Actual subnet mask is this one. This one is the host bit. These all are network bits. But this, whenever you are advertising likewise subnet mask, these bits will be on. Then this will be, sorry, this will be off and this will be on, which in this 255 only we are advertising. But in wildcard mask, whenever you are advertising likewise, it will be assumed like this is the off and this one only on. Opposite to subnet mask. And here I am giving as a 24 means 0.0.0.255 and area. Here I should have to take any area. For this I'm configuring totally area 0 only now. Area 0 and network 192.168.1.0. and wildcard mask 0.0.0.255 and area 0. That much only. Exit. And router 2. Enable config T and router OSPF 100 and network 12.1.1.0 0.0.0.0.255 area is 0. See, now neighborship will be established. Just wait a second. It's 10 seconds. Z neighborship, the loading is full state. Loading done. Adjacency is formed. whenever just you advertised both end prefixes. If you are see again, I'm doing here different area like area ID should match likewise we discussed, right? And they see down now, interface is down. Just I will now command, then I am using now here 10. 1, 2, 3. Wait for 10 seconds. I'm using different area IDs. See, received invalid packet, mismatch area ID from backbone area, must virtual link but not found from 12.1.1. fast Ethernet 0/0. Understood? The virtual, if you configure as if you want, with the help of virtual interface, you can make the area 0, that will be possible. Otherwise, it won't possible. Mismatch the area ID. Understood? Here you are getting the some drawbacks here. Area is not matched. That is the reason here it is showing the error. This router is sending hello messages. Hello messages. Save every not hello. The extart stage, it will be happen. Area ID must match. It will be sending the hello messages, but it is not giving the reply. Error is there. Hello parameter, area ID parameter is not matched. That is the reason. Likewise, the parameters must match. Then only neighborship will be found. Fine. Now here again use area 0. Now wait for 10 seconds. It will be neighborship will be found. Network, again I am advertising this prefix 23.1.1.1, 23.1.1.0, and wildcard was 0.0.0.255 and area 0. And network, I'm advertising now LAN prefix 192.168.2.0 and wildcard mask 0.0.0.255 and area is 0. Something I haven't configured, that is the reason. 192.168.2.0, then
Sir,
here
area
here
spelling.
no here not area spelling. Here I have configured 4 bits only, but I have configured 5 bits. That is the reason. Got it? You can give the question mark. If it is right, then only it will be show. Otherwise, it won't show. See. Likewise, whenever you are real time you are configuring, give the tab. Use the tab. Okay, just a tab. Then it will be show the next command. If it is not showing, then type something. You did something wrong. See, I'm using tab. Question mark. Unrecognized command. Likewise, it will be show. In real time, you use question mark and tab also. 0. Advertiser 3 prefixes. Done. This router. Enable config T router OSPF 100, then network 23.1.1.0 and wildcard mask 0.0.0.0.255 and area is 0. And another network LAN prefix network 192.168.3.0 and wildcard mask to 0.0.0.255 and area is 0. Done. We have to check to verification. We have the routing tables. Show IP for neighbor table, for a database table, and IP routing table. Before that, we'll check the IP protocols. Show IP protocol. See, verification. Here you advertised 3 prefixes. You have one LAN prefix, second LAN prefix, and third LAN prefix. 1, 2, 3. 3 LAN prefixes you have with the distance is 110. AD value is 110. And we advertise networks here. This is a directly connected network. This one directly connected network, and this one the directly network. In this router, we advertise 2 networks. Up to maximum 4 paths are available for this router. And for router ID, it will be select as a highest prefix ID. This one. See, 192.160. I haven't mentioned here router ID. That is the reason it will be take as a physical interface. Which one is the highest one? In between this or this. This one is the highest physical IP address. In this, you can guess which one is the highest prefix physical IP interface. Which one is the highest physical interface in this case?
192.168.2.1.
Great. Can check. Show IP protocol. See, router ID is selected 192.168.2.1. This one is the router ID. First, it will be check as a loopback. First, it will be select whichever the router ID. How we will configure? Config T router OSPF 100. Then give the question mark here. It is showing router ID. Router ID for this OSPF process. Just router ID 2.2.2.2. Nothing is required. Then this much only 32-bit. If we configure router ID, reload use clear IP OSPF process command, if it will be take effect. Otherwise, it won't take the effect. Show IP protocol. See, now it is not affected. If you want to affect, use this command clear OSPF process. Show IP protocol. No, not taken. Okay. I have not mentioned a S here. Why? Now I mentioned that is the reason it has taken. Quick charges. Got it. And we'll check the routing protocols. Now check the show IP neighbor. OSPF neighbor command will check the neighbor table. See, this router having 2 neighbors for this one and this one. These are the router IDs. Okay, got it. This is the router IDs. If you want to check here, it will show different. Show IP OSPF neighbor. See, only one neighbor it is having. That is the reason it's showing. Otherwise, I'll change the router IDs. So the confusion will be clear. Router. Can you tell me anyone how I can change the router IDs? Can anyone? Just now we configured. How can I change the router ID? How can I give the router ID command? Anyone? Router ID only. 1.1.1.
Name?
how can I change the router ID? I am asking about this question with the help of router ID command. Once I'll move to the router OSPF configuration, then I mentioned here router ID. Then I have given the router ID.
IP router ID.
Yes. Clear. IP OSPF process. Yes. And now it will show IP protocol. It will be effective. Check here. Now I'm checking here. Neighbor protocol show IP OSPF neighbor command. With the neighbor command, see only I do have only one neighbor in this command. Earlier we got 192.168.1.1. Now it will, here you can change, some changes will be happen. See, now with the help of this is the router ID. Neighbor in the sense router ID. Okay, and the priority is 1 up to 255 we can change it. And the state is BDR. DR&BDR election will be happen based on the DR router only. The master router will check which one is that. This one is the BDR routers. Both are BDR routers. Show IP protocols. Routers, neighbors. Both are the BDRs. Understood. So IP OSPF neighbor. See, DR is this router is DR because of this prefix is highest. Okay, this router is DR router, and both are different BDR routers. This is the not BDR. This is the which one BDR. So IP OSPF neighbor. DR router is this one, and these are the BDR routers. Other routers you can also the other routers. And we'll check the show IP routing table. Here with the help of OSPF we advertised OSPF. This is the OSPF prefix 23, and this is the OSPF prefix. How it is coming from, where it is coming? Via this interface. This interface, this prefix and this prefix. You can ping it also. You can ping it. I'm directly pinging from this interface to this IP to this IP. This IP to this IP. Okay. Just try to ping. Three dot two. One packet will be dropped. One. Third one. Third one. Something happened in between only. This gateway is not pingable. It means We'll troubleshoot it. Two 3 dot 1 dot 1 dot 1 dot 2. For this interface also I'm not able to ping. Ping 2 3 dot 1 dot 1 dot 1. The packets are up to here. Okay, fine. But when I'm trying to ping in this router, show IP OSPF neighbor. So IP route OSPF. Uh, 192.168.3.2 is. The problem is in this packet tracer, it is showing both are BDR, BDR only. It won't show likewise. One is BDR and another one is other router. Then only the packet will be transferred. That is the reason this packet tracer issue is there. If I am trying to ping here to here, here to here, it will be happen. See, you can check it. I'm trying to ping from and here to here also. Three dot two is 1.2 is both end I am reaching. Here the issue is there. It is showing both are BDR. It won't show likewise. Only in this segment, only one router has the BDR and other one is the DR other. We'll check it tomorrow. We'll troubleshoot it if till now anyone having any questions? Configuration part. One more thing, database table we'll check. In this database table, what I told, show the database, show IP OSPF database. Show IP OSPF database. We got, see what I did, this area is 10. That is the reason. I haven't router link status is 10 now. I think I did the mistake. Have configured area 10. This. There you can find out. A database means different areas. Okay, we'll check it tomorrow. If you have any queries, come with questions, join with questions. Guys, till now any questions?
No.
Do you have any questions? If you have any questions, then say, otherwise wait and stop the recording, then raise the question.